Hot Extrusion, a video presentation by Haozong Huang, Jonathan Sanchez, and Brian Toth. Hot extrusion is a process used to create objects of a fixed cross-sectional profile. The desired material is first heated to 50 to 70% of its melting point, after which it is extruded through a die. Heating prevents work hardening and makes it far easier for the material to be pushed through the die. Most hot extrusions are conducted between a pressure of 35 and 700 megapascals. The three main components of a hot extrusion machine are the billet, ram, and die. The billet is a stock piece of metal that is extruded. The ram is the component that applies pressure to the billet. The die is a block with the hole that the billet is pushed through, often made of hard work tool steel. This design simply shows how a cavity can be added to a component, with an inverse die extending from the ram and pushing through the die. There are three types of hot extrusions. First is forward or direct hot extrusion. The part that is being extruded travels in the same direction as the ram that is forcing it forward. Next is backward or indirect hot extrusion. For this process, the billet and container move together while the die is stationary. The part that is being extruded travels in the opposite direction of the ram. Last is hydrostatic hot extrusion. For this process, the billet is completely surrounded by a pressurized liquid, except where it interfaces with the die. There is no friction between the billet and the container, which allows for a much faster extrusion time. There are a plurality of compatible materials for this process, each of which correspond to a variety of applications. Many metals are used for extrusion, such as lead, tin, aluminum alloys, copper, and titanium. Low carbon steels are also used commonly in hot extrusion, while high carbon steels and titanium are much more difficult to extrude and rarely used. Plastics and ceramics can also be extruded for this process. That being said, aluminum is by far the most common metal. Here are just a few applications of hot extrusion and the corresponding metals. Aluminum is used to create mullions for windows, heat sinks, framing systems, and tracks. Copper is used to make tubes, magnesium, aircraft parts, and zinc is commonly extruded to create handrails. This process is primarily used to create parts that have a constant cross-section, such as this box on the left-hand side. Hot extrusion can also be used to form more complex parts, such as this tapered box in the middle. However, it is very difficult to create this shape, as it requires the use of multiple dies in conjunction. Very complex shapes, such as this chess piece on the right, simply cannot be created using hot extrusion. Precision and tolerance vary greatly with size, material, and two-dimensional complexity. For a typical aluminum extrusion, you can expect a cross-sectional tolerance of 8 thousandths of an inch, a straightness of 13 thousandths of an inch per foot of length, a twist of half a degree per foot in length, and a wall thickness within 10% of the desired output. Cost also varies with size, material, and two-dimensional complexity. From left to right, here are the costs per foot of the following aluminum pieces. $14.40 for this solid aluminum rectangle, $2.28 for this small aluminum flange bar, $4.08 for this aluminum-shaped L-bar, and $6.12 for this aluminum T-slot bar. The benefits of hot extrusion over other similar processes in its class are that you're able to create three-dimensional parts while only applying one-dimensional hydraulic force. You can accomplish this simply by cutting the extruded bar after extrusion. Second, there's a great amount of material variability to select from. The most important thing, however, is that hot extrusion allows for very high production volumes while keeping the cost at a low level. Generally speaking, hot extrusion is best from the order of several kilograms to several tons, after which point metal rolling becomes more cost efficient. There are some design guidelines that should be heeded before the process is started. For cost-efficient production, it is better to have a uniform wall thickness, since extreme changes in wall thickness can cause extrusion to cool unevenly, thus increasing die stress and reducing productivity. Also, simple and soft lines and radius corners will extend the life of the die. You should make sure that the workpiece is symmetrical and do not and does not have deep or narrow channels. It is also recommended to avoid having many cavities and hollow profiles because they are very complex and expensive to produce.